Chapter 6, problem number 78. The drawing shows a version of the loop trick for a small car. If the car is given an initial speed of 4 meters per second, what is the largest value that the radius can have if the car is to remain in contact with the circular track at all times? Okay, so we're looking for the maximum radius. So that would occur, the maximum radius would occur when the car just leaves the track. So in other words, the normal force is 0. Net force then, of course, would be the weight of the car. Okay, so the net force is the weight of the car and its occupants. Now we know the speed of the car here, and that's given as 4 meters per second. So the energy of the car here I'm going to say is kinetic. I'm going to call this level the zero potential energy level. So we have 1/2 mv squared equals, at the top we have kinetic energy. So speed at the top should be equal to the square root of rg, which we showed in a previous problem. Okay, I forget what number it is, but a previous problem. So if we square that, we just get rg, and we want this to be a maximum value. And we add that to the potential energy, which would be mg2r. So the m's cancel. And solving for r, let's see what we get. So we have v squared over 2 equals r max times g over 2 plus 2r max g. So what does that equal to? Okay, so that would be 5/2 r max g, right? So let's see, take 2 over 2, so we have a common denominator, so that's 4 over 2. Right, so 5/2 r max g then is equal to v squared over 2. 2 appears on both sides, so we can get rid of the 2. Solving for r max, we get v squared all over 5g. V is 4 meters per second. We square that, divide that by 5 times g, let's call 10 meters per second squared. So R max is 0.32 meters, which seems awfully small.